So the next question is the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in the air is 0.2 Newton. So we have to find what is the distance between the two spheres, and B part, what is the force on the second sphere due to the first. Okay, so what is given in your problem? Given the electrostatic force is given of what? Of two charges, right? The first charge is, let me take the first charge as Q1. Q1 is 0.4 microcoulomb. So what is Q2? Q2 is given as minus 0.8 microcoulomb. Okay. So you know that here it is plus, here it is minus. So the first charge is going to be positive and the second charge is going to be negative. Okay. So by the law, you know that positive and negative charges will attract or repel. Okay. So positive and negative charge will attract. Okay. Will attract each other. The force between these two charges will be attractive force. Okay. So which force is given? Electrostatic force on a small sphere of charge Q1, that is charge on 0.4 microcoulomb is given. So what will be the charge? So this will be the direction, right? So since it is attracting towards Q2. So I can represent it as F1 comma 2. What is this charge? This is the charge on Q1 due to Q2, which is attractive in nature. Okay. What is the value? Value is given 0.2 Newton. So understood this? Now we are going to find out the value. We have to find out the distance. Distance is equal to R. So what is your distance between? So let me take another color. So this is your distance between the two charges. Okay, R. So by Coulomb's law, you know that the electrostatic force between two charges is given by, what is the formula? F is equal to 1 by 4 pi epsilon naught into magnitude of Q1 Q2 divided by R square, right? So what is 1 by 4 pi epsilon naught? Which is equal to the constant 9 into 10 raised to 9 Newton meter square per coulomb square. So I am writing it as coulomb minus 2. Clear till this? Okay. Now from this you have to find out, F is given. You have to find out R, right? So R square is equal to, just reconfigure. Just bring this F down. So 4 pi epsilon naught magnitude of Q1 Q2 divided by F. Okay. So this will be a formula. Now, can we substitute the value? Instead of 1 by 4 pi epsilon naught, 9 into 10 raised to 9 Newton meter square coulomb minus 2. Okay. Now, what is your charge? Here only magnitude we have to take. So, there is no sign. Okay. So, first charge is equal to 0.4 into micro. Micro means 10 raised to minus 6. Okay. Coulomb into, second you have to eliminate your minus. So, 0.8 into, here also it is micro. So, 10 raised to minus 6 coulomb divided by, what is your F? F is equal to 0.2 Newton. Okay, 0.2 Newton. So can we do cancellation? Here you have 1 Newton, here you have 1 Newton. It will get cancelled off. Here it is coulomb minus 2, here you have 1 coulomb. So it will get cancelled off. Now here you have 0.2 and 0.4. So this will become 1 to is to 0.1. Here it is 0.2. Okay, now which is equal to 9 into 10 raised to 9 meter square into 0.2 into, here you have 10 raised to minus 6 minus 6. So 10 raised to minus 12. Okay, 6 plus 6 you have to add into 0.8. Okay, now can I bring this 0.1 towards your numerator? So when we convert 0.1 into a whole number, 0.1 into 10, right? Similarly, you have to multiply the same 10 in the numerator, or I can write 0.1 as 10 raised to minus 1. When it comes to the numerator, it becomes 10. Clear? Now, so this is your value which you have got. Now you have to be careful because there is decimal multiplication. So how will you do decimal multiplication? Do normal multiplication, then you see after point how many digits is there. Here you have 1 and 2, totally 2 digits. So the answer is what? 8 2s are 16. So how will you do? You have to shift 2 digits towards your left. So it will be 0.16. So 9 into 10 raised to 9 into 0.16 into 10. Okay. This is your answer. So I have left something, yeah, 10 raised to minus 12. Okay. Now can we multiply again? Here it is decimal multiplication. So follow the same rule. Do normal multiplication. 6 nines are 54. Okay. 1 9 is 9. So you will be getting 144. Since you have after the point 2 digits, shift 2 digits towards your left. So your value will be 1.44 into 10 raised to, can I, here it is 10 raised to 9, here it is 10. So totally it is 10 raised to 10 into, what you will be getting, 10 raised to minus 12. Okay, so what will be the value? 1.44. Here it is 10 raised to 10 minus 12. So 12 minus 10, here we will be getting 10 raised to minus 2. Okay, can I convert it into a whole number? So I can write it as 144 into 10 raised to, what will be the value? 10 raised to minus 4. Okay, convert it into a whole number. You know this formula, right? Convert it into a whole number. So you have to multiply by 100. So denominator also you have to multiply, divide by 100. That 100, when it comes to the top, it will become 10 raised to minus 2. So now what is your r square? R square is equal to 144 into 10 raised to minus 4. So what will be your r? R will be equal to root of 144 into 10 raised to minus 4. Okay. So what is your r value? Root of 144 will be nothing but 12 into 10 raised to minus 2. So here it is meter square, right? So you will be getting meter. So I can again write it into 10 raised to minus 2. So I can write 0.12 meter. Okay. So this is your value of your radius r, distance r. Okay. Distance r. So this will be your distance r, that is the distance between two charges will be equal to 0.12. Now the question is not at over. What is your B part? What is the force on the second sphere due to the first? So the force on the second due to the first, you know that here it is negative, here it is positive. So it will be an attractive force. So that's why you have the direction of arrow mark towards Q1. So I can represent it as F21. So what will be your force F21? It is the force on charge Q2 due to Q1. So what is your force? The force F21, which is the force on Q2 due to Q1, which is nothing but it will be attractive or repulsive, because it is both are different charges or different signs. You will be getting it as, it is unlike charges, right? Therefore you will be getting it as the force will be attractive force. So what will be your force? Attractive.